Okay, now I want to show you something fast because some students they ask me, say, make I teach them or make I show them how to balance chemical equation. Now, I just want to use this one as a case study. Before the chemical equation. No, first of all, the reason why we dey balance chemical equation is just to obey one law. And that law now they call law of conservation of matter or mass. And that law state talk say matter is not destroyed, but it is transformed from one state to another, which means matter cannot be destroyed. You cannot break matter, cannot divide it, but you can change it from one form to another. Now, see that law talk with that. Now, that is why we balance chemical equation. Now, what's need for this board now? Now, example of chemical equation. You understand? Make I just use this one. Take explain how to balance chemical equation. Now, every chemical equation they get two sides, the left hand side and the right hand side. Now, for this one on the left hand side, this one on the right hand side. We they call this left hand side, we they call them reactant. Get here call reactant. And we they call this right hand side, we they call them products. So which means now this arrow here now it separates the reactant and product. Now this equation not dey balance. How I take note? Take for example, all the carbon wey dey for this reactant, all of them now one. Only one carbon dey here. And for here, carbon now one. Carbon dey okay. Now oxygen now two for this place and one here, which means all the oxygen for this reactant side now three, but for here now two, which means it is not balanced. So as far as say only one atom or element not dey balance for the chemical equation, it means say the entire equation not dey balance. So my plan now, my target now to balance this equation, make it be say the number of atoms of oxygen and carbon for this side now the same thing with one wey dey for here, which means if I get one carbon here, I will get one here. If I get three oxygen here, I will get three here. And that one they call say the equation dey balance because nothing is lost. Everything wey dey for here, they show for here. And so that law talk. Now, for what I go do be say, I go assign coefficients. That is, put number here, put number here, put number here to ensure say it will be balanced. And take note, say no time, no good triumph, no triumph. Say because say you have three oxygen for this reactant side and two dey here, you want to go change this place, come clean these two, come write three, don't triumph. That one na wrong something when you don't do. So what you go do be say you go add coefficient, you go put values for this place, values for this place, and value for this place. Now to balance this chemical equation now at this your stage, I go advise there are only two methods wey you go fit use. The first method na try and error method or balancing by observation. So it's either you call am try and error or you call am balancing by observation. And I will teach you only the second one, which is balancing by mathematical method. That first one, no good time I will teach now to make the video not dey long. So I'll teach you by mathematical method because that try and error method, in a way, if you not too sabi how to balance equation, it will waste your time well. So make I teach you by mathematical method. Wey be say even though you go solve, you will spend small time, but you will know say once you finish, you get your answer. And so this one there. Now I talk say before you do balance equation, you will add coefficient, put values here, put values here, put values here. Now what I will do for you be say the possible locations where I'm supposed to add values to this equation, I will label them. Yeah, I will label here X, label here Y, label here Z. So my target now, my work now, are to find the value for X, find the value for Y, find the value for Z. Now, this entire equation now only two elements there, two elements, carbon and oxygen, only two. So which means carbon, that is for carbon, the unknown there attached to carbon now X. So how many carbon there for this reactant side? Now one. So which means I have X. Then the other side, the unknown attached to carbon for here now Z. How many carbon there here? Now also one. So I'll have Z. Then I also have oxygen. Oxygen. The unknown attached to oxygen now X. How many oxygen there for this particular place here? Now one. So I have X also. Plus I no go put equal to here because I never read the reactant side and the product side. Now plus the unknown attached to this second oxygen is Y, but we have two oxygen here, two oxygen. So I have two Y. Then to this other side now, I have two Z because the unknown attached to oxygen is Z and this oxygen is two here. Take note, say this value here or this unknown here, it dey affect both carbon and oxygen, but these two here they affect only oxygen. Now, if that is the case, I will call this equation 1, call this equation 2. Now, from equation 1 now, Now, one thing I will do for you is say I will make my first unknown to be equal to 1. This method work for almost 100% of all the equations, but not all. Now, if I make x equal to 1, be my first unknown, then from equation 1, if x if x if x is equal to 1, from equation 1, z is equal to 1, because equation 1 talk say x is equal to z. So whatever value wey x get, na z get. So since x is equal to 1, z is equal to 1. Now I know wetin be x now, I know wetin be z. I go fit put am here, put z here, put x here, and get y. From equation 2, x is 1 plus, that is x is 1 plus 2y equals 2 times 1, that's z, because z is 1, so 2 times 1 is 2, that's 2. So what I will do here, I will get 2y is equal to 2 minus 1. 2y is equal to 1. But the next thing is to divide both sides by 2. If that is the case, I will get y is equal to 1 over 2. Now I don't get wetin be x, get wetin be z, get wetin be y. Now my next thing is to put my values into this chemical equation. If that's the case, my z na 1, the same thing, plus my y na 1 over 2, 1 over 2 whole 2. My z na 1 also, CO2. Now the next one I go do be say, since I get fraction for this place, I have to remove the fraction. I cannot leave it like that. So I have to multiply every substance here by 2 to remove this fraction. If that is the case, I'll get 2CO plus O2 gives you 2CO2, which means if I multiply this by 2, I have 2CO. If I multiply this by 2, the fraction goes off. If I multiply this by 2, I have 2CO2. Now, make we check now whether this equation get balanced. Now, make we check. See what happen here. 2 carbon dey for this side, 2 carbon dey here. Oxygen now 4 for here. 2 times 2 now 4. For this place, now 4 also. 2 for here, 2 for here. So 4 oxygen there, 4 there. 2 carbon there, 2 there. Now, don't forget, say I talk, say these 2 in dey affect both carbon and oxygen. But this small 2 for here, wey they call subscript, affect only oxygen. That's why for this place, this carbon now 2, while oxygen for here, for this place now 4. I hope you understand. Abeg, share to your friends.